First and foremost, I want to welcome everyone for attending the No Code Machine Learning for All Masterclass. I'm Joseph Green. I'm a third-year PhD student at Boston University and the advisor for the IEEE-HKN student chapter here at Boston University. It's honestly been an exciting last couple of weeks working with the Neuton team to be able to turn this into a reality. And we're very excited to bring you this masterclass in conjunction with Neuton to teach you a little bit more about not just AI and machine learning, but the awesome and innovative methods that Neuton's using. In case you're not familiar with the company, Neuton's a disruptive machine learning company that is defined by their self-generating compact models that can be up to 1,000 times smaller than the competitor. So it's an awesome platform that for many applications is free to use. And as we said, self-generating. It doesn't take any prior coding experience to create something tangential. And on top of that, we hope through this masterclass, you're able to get an introductory perspective into AI and machine learning, as well as get an opportunity to explore this awesome model with this incredible company. And with that, I'd like to turn it back to our panelists. And once again, thank you all for attending. It's going to be a great next couple of hours.
Thank you. Thank you so much. Blair, can you switch on your video? I see that you have one question. If it's about some technical settings, can I help you?
I think that was in regards to the auto transcript. But what
okay.
I'm going to attempt to do, which is always kind of like a needle in my side, is disable all of my notifications because for some reason they keep popping up, even though that I am trying to cancel them. So my apologies for everyone if we hear any notifications, but I am hopeful that I have disabled them. So just please give me a moment, and hopefully everyone can see my screen and Slack.
Yes, you can see. Yeah, we
Others.
can see you now, but not your screen right now.
Okay. All right, I will share my screen in just a moment. All right, so here we go. All right, and so thank you, Joseph, for the introduction. And I think that, as you kind of mentioned, our objective really in a couple of different ways is we're looking to promote, let's say, the community. And I think this is definitely an opportunity for us to do that. So as we progress throughout our discussions, there's an opportunity for you guys to ask some questions along the way. Where possible, I will do my best to try to answer them. But if I'm not able to answer them, then maybe some of my colleagues who are also joining will also have an opportunity to answer them. So at least for us, let me just begin. So today's discussion has been, I would say, not necessarily a long time in making, but we've had the opportunity to interact with Joseph for some time over the last few months to begin to put together a program that we believe that all of you guys can get some value out of. And the focus of our conversation today is really around, as we say, being able to build models, or as it relates to having a zero code solution from an ML perspective. And our focus today will be a little bit more as it relates to edge devices, be a little bit more as it relates to being able to produce solutions as it relates to automation. And we have a very diverse audience, we understand this. So some of the individuals that we have in this audience, and just give me just a second, I will plug in my USB device. But we have a diverse set of individuals in our discussion today. Some individuals are fairly new to machine learning. Some of you guys might be, let's say, experts. We appreciate that as well. But also, as you guys know, machine learning really spans across a number of different industries. So how our arc of today's discussion will go will be a little bit more introductory. And as we kind of go through those introductory phases, we'll get a little bit more into some technical discussions. But for those just by way of understanding, there may be some discussions here that you might find to be a little bit more introductory. But let's start first as it relates to our agenda for today. So for today, we kind of have three phases. So phase number one, which I'll have the privilege of sharing with you guys today, will be a little bit more about our introduction to AI. What is AutoML? Some of the history as it relates to AutoML, where we are today, where we kind of see ourselves moving forward. And then number two, we'll be joined by one of our partners, ARM. Hopefully you guys are familiar with ARM, but ARM is an extremely influential organization because most, if not all of their IP or their intellectual property, you would find a number of different microcontrollers or sensors that if you had the opportunity to work with, you would find in your organization. And then number three, but also included in my session, we'll kind of step through with you guys the opportunity to build a model. We'll kind of demo that, and then we'll certainly give you guys the opportunity to do that on your side. Towards the end, if you guys are participating with us from end to end, you have an opportunity to earn a certificate for us as it relates to participating through our masterclass. Now, some of the times that you might see on today's screen right now is a little bit what we think are some ranges as to what we will follow. So please forgive us if we kind of go a little bit shorter, or we go a little bit longer than some of the times that you've mentioned, but we'll start from there. And then in the third class, one of my colleagues will be joining me. His name will be Andrew Glutt. And more importantly, this guy has no technical skills, but he will take us through the practical class as well to demonstrate how we can take advantage of such a solution. So even though today, just by way of introduction, if I haven't had the opportunity to meet you guys, my name is Blair Newman. I am the CTO at Neuton.AI. Neuton.AI, we are an organization of Bell Integrator. Bell Integrator, we've been around for almost going on 20 years. We're based in San Jose, California. Historically, our background has been more so about systems integration, but over the last 5 to 6 years, and I've been around with the organization going on about 7 years, we've really kind of embarked on this journey of being able to produce a solution that enables machine learning for everyone. And we remember, and we take this approach in a very literal sense that hope we'll be able to demonstrate for you guys all the way. Now, one of the areas that we're extremely focused on is being able to enable machine learning on the edge. And what does that mean? Of course, it means a lot of different things for a lot of different individuals. But more importantly, we want to enable you to be able to produce a predictive model so that maybe you can enable it or integrate it into your smart device or into a microcontroller, or it could be whatever particular workspace that you're in, whether it's healthcare, whether it's from a financial perspective, etc. And we're pretty active as it relates to this community. We participate significantly as it relates to the TinyML community. Some of you guys may be involved in the TinyML Summit that is coming up in March, but you also can find some of the activities that we are extremely active in Capterra or in Product Hunt as well. Our Hackster.io is an area that some of you guys may be familiar with. And once again, highly want to encourage all of you guys, if you have any questions, you have any comments, feel free to make some of those comments in our chat forum, and then are in the Q&A session, and we'll be happy to answer those questions along the way. So starting first, one of the areas that I like to always start with, because we have a very diverse audience today. As I mentioned earlier, there are some individuals who may be new to machine learning. There are some individuals, maybe you guys are experts, and there are some individuals who may be in between. Maybe you're an embedded engineer. But one of the things that I like to level set on is begin to understand what is all of the various technologies and terminologies. So I say that because we kind of, to some degree, we kind of all have a view. What is edge computing? For some people, edge computing could be just a computer or a virtual device that's operating on the edge. For some individuals, it could be that you have a smart device that you're wearing on your wrist as it relates to whether maybe it's the iPhone, maybe it's Fitbit, etc. But more importantly, what we're really here to talk about is artificial intelligence. And more importantly, how that begins to integrate with some of those physical devices. And how we accomplish this, or the areas in where we accomplish this, is with machine learning. And machine learning, maybe as some of you guys know, is the approach as it relates to being able to produce, let's just say, systems or algorithms that can make intelligent decisions, presumably like ourselves, so that we can predict certain things moving forward. Now, at least for myself, I began to look at me and I said, how successful am I predicting the future? More often not very successful. But we have algorithms, or there are algorithms that are out there in the platform, out there in the ecosystem, that allows us to do this with a high degree of accuracy. And then lastly, we begin to talk about TinyML. What is TinyML? TinyML is where I like to say personally, where the physical world meets the digital world, and we integrate the two. So whether you have IoT sensors, etc., our objective is to bring some of those physical devices that are out there from an edge computing perspective to bring them intelligence. And that's the basis behind TinyML. And we'll certainly be in a position to talk through those as we move forward in today's discussion. So that's kind of a little bit of a background as to what we're looking to focus on today. But more importantly, let me tell you some of the areas that I really enjoy, or that personally I enjoy as it relates to TinyML and as well artificial intelligence. At least for myself, I've had the opportunity not only to speak to you guys today, but also engage high schools. And more importantly, one of the areas that I always like to highlight is that when you begin to think about AI, when you begin to think about machine learning, when you begin to think about edge computing, when you begin to think about machine learning, it is vertical agnostic. So if you might begin to kind of look at our screen today, irrespective as to where you may be in your career, there's more than likely an opportunity where there is an applicable business case where you can kind of apply these technologies to enhance whatever you may be doing at the moment. It doesn't matter if it's healthcare. It doesn't matter, of course, if it's, what we like to talk about, smart city, communication, education, cybersecurity, of course, but also in sports. I don't know about you guys. I'm a big sports fan. So it doesn't matter if whether or not it's football, doesn't matter if whether or not it's baseball, basketball. They are hiring individuals that are focused in this particular area, only telling them what are the next steps that they should take as it relates to the next play or the next engagement. So it's everywhere. So I like to say that our opportunities are endless as it relates to how you can apply these specific technologies moving forward. Now, what I would like to do right now is kind of share with you guys as we begin to kind of now engage on where is AI in our environment? How often do we touch AI? And if you were to ask me, I would say you touch AI everywhere. And maybe, one second, I am going to stop for a second because I'm not sure if when I shared my audio. So I will do that just in case you guys weren't able to hear the audio. My apologies. I'm gonna start again.
We can hear it.
Okay, excellent.
Track pumping, everybody jumping. Go ahead and twist your back and get your body bumping. I told you leave your situations out the door. So grab somebody and get your ass on the dance floor. Hey, Nora, attention on your work, please. No. music. Thanks so much, Lucy. I'll remember that. Hello, Rachna. No need to answer me yet. The system is still processing a lot of information, but I'm going to count to 3. Try to count with me in your mind. 1, 2, 3.
Oh my God, where am I?
It's all good, Rachna. Welcome to Upload.
There's an invalid syntax error on line 682.
Yeah, what is that? That's another null pointer. I got it.
Ah, yes, nailed it. Okay, the class definitions still need work.
God, no. I gotta veg a little. I'll see you later, buddy.
No, dude, we are
Bye.
so close.
Car,
Yes, Nathan.
clean camera lenses, please.
Begin cleaning. You are 19 minutes from your destination.
Let's go.
Officer, it just started racing. It was the craziest thing. I will take it into the service ASAP. I'm on my way to my mom's place for Thanksgiving. And could you imagine if they were waiting for me at my car?
Mm-hmm. Car, what's your story? Lost consciousness for a minute. We'll update antivirus software now.
Yeah, you do that. There's a human life back here. Wow. AI is just the worst, isn't it?
Okay, you can go now. Take it in soon, though. I don't want to see you again.
Oh, no? What station are you in, SoCal?
Should I call your longtime girlfriend Ingrid and tell her you will be late?
Okay, see, that's not supposed to happen.
Bye.
God, it's called being nice. Whose car are you anyway, huh?
Citibank's.
Who's making the payments?
You are.
Me. That's right. Let's go.
I don't know about you guys, but the only thing that I actually initially kind of identified when I saw this particular video was that he just recently went to In-N-Out. But that's kind of my personal preference. And depending upon where you're at, maybe you might like some Shake Shack or something like that. But I think what we wanted to begin to highlight is as we begin to kind of build on what are some of the areas where we are finding and engaging from an artificial intelligence perspective. And maybe you identify some of these areas yourselves, whether it is, you know, self-driving cars. It doesn't matter if it's Google, it doesn't matter if it is Tesla. Drones is also an area that, believe it or not, is extremely active in the machine learning space, whether it is beginning to look at, if, say, as an example, if someone is fishing in some of the wrong locations that they're supposed to be in, or just observing crops and whether or not if those particular crops are ready to be harvested. But again, as I mentioned prior to even this particular slide, there's a number of different areas: financial services, voice and image recognition, computer vision, natural language processing, you name it. It's an area that we're kind of all touching on an extremely regular basis. Now, this is a very interesting component because for me, this was something that I've always been kind of fascinated with. When you begin to kind of look at the growth of machine learning, number one, I like to begin to highlight that machine learning, artificial intelligence has been around for an extremely long time. Even just 5 years ago, we have witnessed, or we've had the opportunity where there has been an ML-based robot. And I can't even say what were the various metrics that she had to meet in order to become a citizen. But Sophia was given Saudi Arabian citizenship. And I'm not sure if you guys are aware of this, but certainly it's something that we should highlight as it relates to the progression of AI or the progression of machine learning along the way. And the same thing whether it relates to Google's self-driving car, which has passed the Nevada self-driving test, and the same thing from a Tesla perspective. Not accounting some of the accidents that they may have had along the way, but we have seen just literally leaps and bounds as it relates to machine learning being more and more and more prominent in our lives. And that's extremely important. But let's highlight something that we witness or we experience every day. Doesn't matter if it's Siri, doesn't matter if it's Alexa or Google Home. Every time that we're speaking into these devices, they're understanding, they're listening to some of the things that we're communicating, and they're making those decisions. And of course, I always like to ask, what are your thoughts in regards to how often we're being monitored? If you ask me, and it's without question, they're always listening, they're always recording, they're always documenting. Everything that we are saying, they are taking account for. And of course, they have to do this because they're looking for their keyword, right? They're looking for us to say Siri. They're looking for us to say Alexa. They're looking for us to say Google Home, which means that they are monitoring us on an ongoing and regular basis. So we are consistently surrounded by, let's just say, not only these technologies, but also the opportunity to take into consideration privacy, which is, of course, extremely important to us as well. But as we kind of gotten closer and you begin to kind of look at, let's just say, social media, doesn't matter if you're on IG, if you're still on Facebook, TikTok, etc., you find increasingly that the algorithms that are out there are more and more prominent, taking advantage of some of our actions. Some of the obvious ones, whether it's voice recognition, if you're doing augmented reality, natural language processing, depending upon where you may be at, smart cities in Europe, algo trading, something that, at least for myself, I've been very interested in is to how can I leverage algo trading in order to make some additional money? And then, of course, from a healthcare perspective, and you name it, financial services, we are completely and always surrounded by this technology that is always engaging us passively, of course, as well as directly. And a lot of times we can't always make the difference. But let's begin to kind of talk about what does artificial intelligence means for us specifically. And one of the things that I mentioned is that we have a very diverse audience. Our audience covers individuals who are new, individuals, I like to say, is exploring. There are some of you guys who are, experts in the field, and that's okay. And as we continue throughout our event today, I hope, and it's our intention that we cover kind of all different demographics. That's our objective here at Neuton. But there are some really big, I would like to say, meaningful numbers that you can begin to take a look at as it relates to why artificial intelligence is important to us. And also, when you begin to think about COVID-19, I can tell you, we worked with, here at Neuton, we work with a supplier on the banking side. They specifically support banks and credit unions from a core perspective. And one of the things that they were able to identify is they were able to easily see and predict how COVID-19 was progressing throughout our country, because they were able to see the behaviors as it relates to all of us as consumers, but more importantly, as it relates to their customers and their individual institutions, they were able to see how the behavior is changing. More individuals were going into the institution. More individuals were going to the ATM. And they were able to map that and see the behavioral changes. And if they were so prepared, they would have been able to predict it. From a data perspective, they were able to see it. But in the end, it told them that, hey, this is something that we want to begin to be on the forefront of moving forward. But more importantly, and needless to say, AI is an extremely opportunistic market that certainly all of us can continue to take advantage of, irrespective as to where you may be as it relates to your career. Now, I will start here, and I can personally say that I have not always been very in tune or a fan of this particular individual, but nevertheless, he has been extremely accurate as it relates to what will AI bring in the future. And this is one of the areas that I like to say, you know, you have to respect whether his prognostication is okay or whether or not he's just been lucky. But Ray has been extremely accurate in being able to detail as well as prognosticate where we would be moving forward, especially as it relates to, you know, machine learning, especially as it relates to artificial intelligence, whether it is 3D printing, whether it's being able to detect, you know, let's just say some of the health of fruits, some of the health of vegetables, etc., and how agriculture will play a part as it relates to artificial intelligence. And by the way, we're going to have a use case that I think all of you guys will find extremely valuable as it relates to AI. And of course, he has some additional prognostication predictions that might be relevant moving forward. But I can say, and I unfortunately have to admit, that he has indeed been very forthright, and not only forthright, but more importantly, accurate as it relates to how AI will continue to play a part in our lives. So I'll just skip forward here, and I'll skip to an area where I truly enjoy. For me, I'm a sports fan. When I begin to look at sports, it's amazing to me how artificial intelligence has influenced sports. If you begin to look at staff now, of course, you have a head coach. It doesn't matter if you're in basketball, doesn't matter if you're in football, you name the sport, even in soccer along the way. On staff, they are typically hiring AI professionals in order to help them with understanding from a statistical perspective, what's the next play they should take? What are the next moves that they should play? And if whether or not, if you're a football fan, from a US perspective, not soccer, from a US perspective, what are some of the steps that you should take? What play should you run? Should you run a run? Should you run a pass, etc.? And we see in a number of different commercials, a lot of statistics as it relates to AWS talking about, you know, how a play was conducted, how a play was successful, what was the percentage of success, etc. But more importantly, we can see that AI is invading all aspects of our interaction, whether it's work, and in this particular case, entertainment, not unless you're a professional. Now, as we begin to kind of look at how do we move forward, we talked about Sophia earlier, but what do we do next? What do we do next is that we begin to kind of look at how artificial intelligence begins to interact with us. And as AI begins to interact more and more with us as individuals, this is the area of opportunity that we see, especially as it relates to our organization, Neuton. This is an area that we are excelling in, and this is something that we'll share with you guys along the way. But first, let's begin to kind of talk about AI as it relates to what it means to us as individuals. Because what it means to us as individuals is a pipeline. It's an understanding as to how we begin to take advantage of AI from a technical perspective. Number one, you need to understand your data. You need to understand your data irrespective as to where you are in your journey from a career perspective. You need to understand the challenges that are out there. Because in the end, from a business perspective, what matters most are results. And then, of course, as we begin to build more and more experience, then we can take advantage of this. So the evolution of machine learning, we can talk a little bit about what are some of the achievements that we have at the moment. What are some of the challenges that we're experiencing to I would say today, but also tomorrow, but also how we can address them, how you can address them. And that's where we're hoping that we'll continue to enable you to understand today and throughout our discussions. So let's start first with what is machine learning. I'm not here to give you, let's just say, a textbook definition. I think all of us are capable of beginning to take a look at the definition and see how it may apply. But more importantly, one of the things that I would like to highlight is when it comes to machine learning, when it comes to artificial intelligence, or if you're in the computer science business, which, by the way, my son is in that area. He always used to tell me, Dad, I'm never going to follow in your footsteps. I'm never going to do this. And then look where he's at today. But more importantly, we like to encourage you guys to begin to understand the data. I always like to say data is king. It is the key that allows for us to take that next step. And then secondly, when we begin to think about how does machine learning interact with us as individuals, TinyML is an area that is extremely important as it relates to us as humans interacting with this technology. And it comes in a number of different various ways. We begin to see time and time again how our compute is accelerating. Some of you guys may know Moore's Law. And we can begin to see continually how Moore's Law is having an impact as it relates to technology, as it relates to, as an example, how microprocessors are becoming more and more and more efficient, especially from an IoT perspective. But more importantly, how can we make those devices intelligent when they have a limited amount of power and a limited amount of compute? And that's an area that we'll be addressing today. So when we begin to think about how does machine learning work, and for you technical guys, please bear with me, but I think maybe you'll understand and appreciate this analogy. So when we begin to say compare, how does machine learning work? Number one, we begin to take a look at, let's just say, we look at human learning. As a student, as an individual, we have to study, we have to understand, but more importantly, it's the content that we need to understand. And you might, let's just say, contrast that to data. But it's a very important concept of the student understanding the data that they are analyzing. And then we talk about, let's just say, maybe a teacher as it relates to being able to analyze that data, being able to put that data into action. For me, that's the most critical thing that I would encourage all of you guys to understand. Once I understand the data, how do I put it into action? How do I produce results where either myself or my business or my organization will get value out of it? And then in the end, we talk about an exam. The exam is nothing more than the results. How do you perform? How do you realize the results that you were looking to achieve along the way? This is the basis. As for us, we like to say that machine learning or artificial intelligence, in this case, because there are other variants of AI, but this is where we like to start. And now I'll share with you, how does it look on the technical side? So number one, we talk about a student. In our case, a student is not an individual, it's a computer, right? And that computer or that particular device comes in a number of different, let's just say, options. You may have a CPU, you may have a GPU, you name it. But at the heart of it is data. I began to highlight to you, junk in, junk out. What does that mean? The quality of data, the understanding of data is the most important thing as it relates to being able to produce an effective model. If you have junk coming in, you're going to have junk coming out. And then lastly, from an algorithm perspective, that's also extremely important. Algorithm, as it relates to teacher, is being able to understand what are the ins and outs, what are the most important features that are influencing your data, what are the most important features that might have the highest predictive value in what you're looking to understand. So that's another area that we'll touch on in a minute. And then lastly, the prediction or the exam is the results. What good if you have, you know, a GPU that has 64 gigabytes of memory? What good is you if you have data? What good is you if you have an algorithm? If in the end, you don't connect the dots and you don't have predictions that provide value to yourself or to your customers. And that's the area where we're focused on. Now here, I'm just going to kind of skip through really quick because it's another analogy, but it's an analogy that internally we truly believe in. We kind of liken machine learning to music. You know, in this particular case, you have data, you have notes. Then you're arranging that data as it relates to algorithms. And then you have a tool. I don't know, you could be playing a violin, you could be playing a cello, you could be playing, you know, a guitar. But what's most important? What's most important is the domain knowledge, how you can pull all of those different things together to produce something that your audience or your customers will find extremely valuable. That is what we believe will, in the future, be the most important thing as it relates to machine learning. Not necessarily the algorithm, not always necessarily the tools, but how well do you know what you're doing? And then as we kind of capture everything as it relates to what's the output. Now, you know, here, maybe we're a bit outdated. I think that kind of looks like an iPod, but, you know, maybe you have some other device as it relates to being able to see the result and hear the result of your outcome. But in our case, we begin to talk about edge devices. We begin to talk about IoT devices. We begin to talk about perpetuating machine learning predictive models everywhere. If you go to, if I'm not mistaken, TinyML.org, their objective and their belief is that in the next 5 years, they will have intelligent devices in over 1 billion devices. That's the direction that we're headed in, guys. And we encourage you to continue to be a part of that. It's essential. But now, how do you do it? How do you get to that step? You may say, hey, okay, Blair, everything that you said is fantastic, but how do we get there? And some of you guys who's been around, you kind of have an idea as to how you get there. But some of you guys who are just embarking on your journey, take a look. As I mentioned, it always starts with data. You may have that data in a couple of different places. Number one, you may have it in a data lake, or you may have it in an existing database. And that existing database could be anywhere. It could be in a private network. It could be in a cloud network. It could be in a data lake. You could be using Spark, you name it. But also it can come from sensors. It can come from IoT devices that are in the field that are not connected to the network. More importantly, we need the data. We need accurate data as it relates to being able to produce a model. And then once you collect that data, you want to be able to have that data or put that data into a context that will allow for us to build an appropriate model. And there's a couple of different techniques that are out there that everyone can take advantage of. When it comes to us, we focus on a number of different areas. We focus on regression as it relates to being able to produce a value. So if you're looking to say, you know, how much power was something consumed? What is the price of my home? As an example, classification. It could be, we say binary classification, which means yes or no. Hey, is somebody going to leave? Somebody going to stay? Another opportunity could be multi-classification. What is my customers, or what are my customers going to consume? Are they going to consume product A, B, C, etc.? Then of course there's natural language processing, and there's also time series. What do things happen over time? Maybe you're in the financial services market and you want to be able to understand and predict how things will occur over time. But more importantly, you have to clean and prepare your data in order to help you produce the result. And then lastly, of course, you have to build a model. Which neural network do you decide? Which algorithm do you use? Do you use TensorFlow? Do you use TensorFlow Lite? Do you use PyTorch, etc.? Something that you have to always take into consideration. And then more importantly, when you get to those 3 steps, I always like to say, hey, you know, that's a shiny light, a shiny object. The reason why I say that is because I know a customer, excuse me, not a customer. I know a vendor who to me it's like Cinco de Mayo, and I'm sure it's getting close. You guys know what Cinco de Mayo is. Cinco de Mayo, typically in the US, you kind of always see this counter. Sometimes it's counting down, sometimes it's counting up. It's getting you closer and closer and closer. And I know a competitor who does this. They're counting the number of models that are built in their ecosystem. And to me, I always laugh because when you ask the next decision, how many models have actually been deployed or implemented in your ecosystem? And that number drops significantly. Building the model by itself without implementation and receiving value, I like to call a shiny object. We like to ensure that we help you take the next step, and that's where we get into deploying a model. So you have the options of deploying a model into the field. You have the options of deploying a model to an MCU, a sensor. You can even, as an example, deploy your models, let's just say in the cloud, and have API access, or deploy your model via the web, and you can do predictions via the web. But let me show you the next step that's extremely more important. Where do you spend your time? Where you spend your time is collecting the data, preparing the data, and building a model. And then, of course, deploying a model, yes, it takes labor. But let me tell you what I always like to say. For me as an individual, I need to drive a car. I didn't give you guys completely a background about myself, but I live in San Francisco, California, or I live in California, in the Bay Area, California. And for me, I need to drive a car. I just need to drive a car. I need to get from point A and I need to get from point B. But I don't want to be a mechanic. It's not my objective to be a mechanic, but I need a car. I need something that will get me from point A to point B. But if there's a problem, or if I need to understand in detail how a vehicle works, that's not my objective. And that's how I began to take a look at, let's just say, machine learning or AutoML. Now, don't get me wrong. We need mechanics, because when my car breaks down, I do need a mechanic. But there are some of us, and a lot of us, that need to just get to the point of a result. My result could be that I just need to get to work. My result could just be, I need to get my son to school. But I don't necessarily need to know the inner workings of a motor, of an engine, of how everything works. And that's where we're at. We're saying, hey, we're here to enable you to get from point A to point B. And some of you, you might want to be that mechanic. Some of you are looking to say, hey, you know, I'm an embedded engineer. I don't necessarily want or need to be a data scientist, but I want to be able to produce the results. And that's what we're focused on. And this is the area that ultimately we're accelerating. Because of course, being able to produce all of these different bullet points as it relates to time and accuracy and cost, it's meaningful. And how can you optimize that? Especially if you're looking to integrate some of these solutions into IoT devices, into MCUs, into sensors. This is an area that we want to continue to be able to focus on. And here, just maybe just a summary of some of the things that I just said. But these are the challenges that we all face. Even though we've been in this space for a long time, we'll still face the challenge of time. We still face the challenge of cost. We still face the challenges of, as it relates to accuracy and size. But I believe that we've been able to check the box for all of you guys and give you guys an option and a solution if you so choose, so that you can accelerate your time to market. You can reduce your costs. You can produce models that are extremely compact without compromising accuracy. And that's the kind of the underlying and underpinning discussion that we would like to share with you guys throughout today. So here, I'm gonna just kind of slip through all of the various slides right here, but some things that we just want to remind you as to what can prohibit you from being successful, especially if you're in the corporate world. You know, if you have this opportunity, whether you're starting your own business, you're being in a startup, maybe some of these areas are not a challenge to you. But one of the things I like to highlight, and again, it kind of reinforces something that I said before. A lot of times we find most of the models, they're not implemented. They're built. It's very easy to build a model. I'll show you how easy it is to build a model in just a moment. But do you make it into production? Does your organization receive value? How many data scientists do you need? How many engineers do you need? How many engineers do you need? Do you have to buy off of the business organization to be able to accomplish this? But now if you can show in a value proposition where you can eliminate some of these headwinds and the friction that you would typically understand, then your opportunity to be successful goes up dramatically. I mean, even Netflix, as they were embarking on their journey, of course, now, without a doubt, they're using a number of different algorithms. But initially, they were a victim too. I mean, albeit 13 years ago, they were a victim. They said, hey, we want to use, machine learning. We want to develop these algorithms so that we can target you, so that, we will say which movie that are short series you should watch. They did it, they built it, but they didn't implement it. And this is where we want to also help you guys understand the value as it relates to implementing these things. So that leads us to problem number 2. I don't like to say problem. I just like to say, hey, there are some headwinds and some challenges that we have to address as individuals. And some of those challenges, and now we will begin to talk about, is automation. Historically, when you begin to think about how do you build a model, maybe you're going to use TensorFlow. Maybe you're going to use PyTorch. Maybe you're going to take on some of these traditional tools. And trust me, I have nothing against all of these different tools. But the question is, how can we now be more efficient? And automation has always just been, quite frankly, it's been in our DNA as a society. You name it. It doesn't matter if it's cars, bikes, the wheel, you name it. We want to, what we started with before ultimately advances, ultimately gets, improvements, ultimately gets optimized, and we begin to do things differently. We begin to focus on what is the result. I remember, maybe I'm a little older than some of you guys. We used to have to do our oil changes. We used to have to change our own tires. We used to have to do all of these different things. And now, hey, my tire gets on flat, I have a run flat. Doesn't go flat, it's okay. Oil changes last longer. Automation is all now a part of our ecosystem. Even if you begin to look at Tesla, et cetera, automation is where we're living. So this is where we are today when you begin to think about what is a data scientist. And some of it is myth. Some of it is just history. You need to be able to have those analytic skills, data mining, coding, you name it. And you need to be able to understand, how do I pre-process my data? If I do feature engineering, which algorithm am I going to use? Whether it's linear regression, logistic, tree-based algorithms, you name it. Is it time series? Is it NLP? Am I going to build a neural network? These are historically all of the different things that you need to consider. But I want you to remember something that I told you before. Junk in, junk out. Doesn't matter how skilled you are from a technology perspective. If you don't understand the data, you won't get the results that you're looking for. So this is where we see moving forward, where the data scientists, where you guys will be moving forward. Because you can use Python, and excuse me for the typo, you can use R, you can use Java, SQL. We do all of that as well. Make no mistake about it. Those technologies, I'm not saying they disappear. What I'm saying is what becomes more important. Where do we see things moving forward? And I'll say in this presentation, maybe I'll just give Yuli a hard time. I don't even think that you're going to have to wait until 2026. I think you have to wait sooner, where you'll begin to see that what organizations are looking for is something different. Of course, they want to make sure that you understand data mining. You want to understand the code. Don't abandon those skills. That's not what we're saying. Analytical skills, please continue to understand those things. But more importantly, you need to be able to understand the business domain expertise that you are working in. So I mentioned in the very beginning, if you're in healthcare, understand healthcare. You're in financial services, understand financial services. The essential skill of being an effective data scientist, especially as it relates to today, is making sure you understand the data that would help you produce the result that will bring yourself and your organization the most value. That to me is it's undoubtedly the one thing that I love to impress upon you guys today. And then of course, we talk about business problem solving. We've heard this term many a times. What does it mean? What does it really mean is having the skill to understand the business problem that your customer, your organization has today, and then being able to transform that into a technical solution where they ultimately receive the result so that their organization has value. I'll say it again. What does business problem solving mean? It means now, from being that technical person, understanding the business problem, converting that, translating that into a technical solution that your organization or yourself can conceive and realize the result. That is the key to ultimately being successful as we move forward. That is the key to ultimately you being successful as you move forward. And of course, what do you need to do that? Creative thinking. We have to kind of go outside of our depth. We have to go outside of our box in order to realize the result. So that's all about mindset. It's all about those different things. And of course, we will share with you guys this data set so you can take a look at it. I'm not always a huge proponent of reading every word on a data set, but hopefully you guys can understand certainly something that I've experienced as a professional, and I believe that you guys will continue to experience as well. So I don't even know if I have to share this particular slide with you guys. And the little guy on the right-hand side, he always amuses me. He has a lot of money, so it seems. But obviously, it goes without saying that being in this particular space from a financial perspective, it certainly can mean a tremendous amount of value to you guys. Now, you know, for myself, I have two kids. I have an older son. He is now 22. He's graduating from college. I have a younger son. He is a junior in high school. And I tell them consistently, I've never worked a day in the last 20 years. I say this without question. I have no doubts about it. I'm perfectly fine where I'm at. And I'm able to say that because I enjoy what I do. I have passion in what I do. Wanting to see my customers have the light bulb go off and realize the results, I find extremely valuable. And it is a principle that I have tried. Again, 16-year-old, 22-year-old, maybe they haven't realized this, but I have tried to instill in them, this is something that they should focus on. Find something that you enjoy. Find something that you have passion about. Even to the degree where at my son's high school, we have a machine learning club where we are teaching kids, 15, 16, 17-year-olds, covering some of the same content as you guys. But one of the things that I love is that it goes across a number of different demographics so that they can find their appeal in the area that they really want to focus on. It doesn't matter. It could be financial services, could be automotive, etc. But more importantly, find something that you enjoy. And then financials will come. We have this on here just to show that, hey, yeah, there's opportunity. It doesn't matter where you're at. But more importantly, I encourage you guys to find something that you truly enjoy. And if you can mix in machine learning along the way, sounds perfect to me. Now let's begin to kind of take a look at what do things look like today when you want to build a model, right? And we kind of call this the old way, but let's just say this is how, you know, maybe you're doing it today. If you're using TensorFlow, you're using PyTorch, you're using Keras. a lot of the time that you spend is on data pre-processing and implementation. That's the reality. It's a very iterative process. Now, our context here is also talking about organizations where typically you have to find that data scientist. You have to have the infrastructure. You have to analyze the data, right? Labeling, et cetera. You have to clean the data. Then maybe you have to do feature engineering, and then you have to create the model. There's a few slides back where I highlighted this, and I'm gonna try to skip very fast, where we discuss what are the big boxes that you go through. You go through these big boxes. You go through trying to get to the point of building a model. And it's a lot of friction. It takes time. And then you hope that you can build a model that has the accuracy that meets your business objectives. That's what we're trying to highlight here. And excuse me, I'm going back forward. And I will be there in a second right here, right? So this is the old model. And then finally, especially if you're looking to now integrate these models into your ecosystem, you have to deploy those models where you see the results that you're looking for, or maybe you don't. We're trying to eliminate all of this. Our objectives here at Neuton, our organization, we have had the opportunity to build an AutoML solution that automates a number of these different things that you see here. We're not asking you to not understand them, but just like, a construction worker, just like a contractor, you know what a hammer is used for. You may know what other various tools are used for, but we're encouraging you that how can you do something that's much more efficient than what you would typically find today? And our objective, our mission, is to be the Excel of machine learning, where it just becomes something that you input data and you receive a result. Maybe you want to be that particular mechanic. And if you do, trust me, God bless you. I need you. If you don't, if you're looking to just focus on a result, that's fine as well. There's a place for us all in this particular ecosystem and where we function as professionals. So what we've done is we've produced a model where once you've identified your solution, you can upload your data, you can identify your target variable. Once you identify your target variable, you can train your model. And you can train your model and then produce the results that you're looking for without needing to invest all of that various labor that you would typically need to do. But again, we're not saying you shouldn't understand Python. We're not saying you shouldn't understand R. All of those various tools, they're very important. But in the end, what are we looking for? Results. And some of the things that we're able to do, we're able to reduce your time to market. You'll see in just a moment, your implementation costs as well as your support costs. And we're able to do this or enable you to do this in just 3 clicks, which we'll show and demonstrate for you guys in just a minute. So I am literally not going to go through all of this, but here is just a highlight of some of the things that we find important when it comes to machine learning. I like to start first with pre-processing. So pre-processing is, hey, you may have missing data. Your data may need to be cleansed. It may need to be normalized, et cetera. Some of your variables may need to be transformed into machine readable format. But we also produce for you what we call an EDA, or exploratory data analysis, which gives you some insight as to what your data looks like before you begin training, right? Junk in, junk out. So we're going to say, hey, here's the data that you gave us, and we're going to give you some insight if the data that you gave us is really something that is valuable, that is going to help us produce a predictive model. I think you would want to understand that, right? And then we'll pre-process the data. And then from there, from a feature engineering perspective, we'll begin to understand all of the relationships between the various variables or the various features that are in your data set. Extremely important. When you have an opportunity, please step through and go through these bullet points. And then we've talked a lot about the progression as it relates to machine learning and TinyML. We continue to see TinyML evolve, accelerate, and grow within the organization. Whether you have an Apple Watch, whether you have a Fitbit, whether you're using Alexa, whether you just may have a sensor in the field, it doesn't matter. You could be using Arduino, STM, Sentient, you name it. There are a number of different IoT devices out there, MCU devices that are out there. For us, we're vendor agnostic. So irrespective as to what you may be working with out there in the field, our solution really appeals and works in your favor. And more importantly, I don't know, this is a very big building, supposedly Google, kind of looks like California, but maybe it's not. But we avoid the connection of you needing to connect back to a data center. We have that solution, of course. If you want to do something via the web, you want to do something via the API, yes, you can. But when we talk about TinyML, we eliminate the need for you to be connected to the data center and be able to operate in the field. It's extremely important for us. Now for here, I'm not sure how many times in my life I've used the word quintillion. Probably never until today, but we do understand there's a significant amount of data that is out there. But here's the most important part. It's less than 1% of that data that is analyzed or used at all, especially when it relates to TinyML, machine learning, et cetera, which tells us, which should tell you that there is a significant opportunity out there if we were to explore this specific area. It's something that we believe we are posed for and prepared for, and we hope that you guys will continue to join us. Now, in the end, if you're going to be involved when it comes to IoT devices, MCUs, sensors, et cetera, you can begin to kind of take a look at how things are progressed, especially when you talk about machine learning. Typically, the more data you have, all of those different things, the complexity of the task, the model size goes up. But what are we seeing from a technology perspective? Especially you guys that are very familiar with Moore's Law, we see that MCUs are getting smaller and the cost is going down. And what are some of the challenges that you're experiencing as it relates to being able to integrate these models into these smaller devices? We help you, we help our customers able to accomplish this without any technical skills in one iteration. One iteration, we're device agnostic. One iteration, we're the most accurate. So again, our focus is on producing the result. And take a look at it. What is the opportunity? I'm not even sure I need to say this. There are billions of various MCUs that are out there in various different sizes. But we are trying to be prepared for the opportunity as these devices come more and more intelligent. Whether you want to look at NVIDIA as it relates to GPUs that are out there, Apple, they have some smaller devices. Then of course there's, Sentient as an example that has a number of different TinyML devices. And it's not just Sentient, there's Renesas, there's STM. I mean, you name it, a number of different silicon providers, they're operating in these various spaces. And these are the organizations, quite frankly, that we're looking to interact with, we're looking to partner with. And these are also the organizations that you would also be looking to work with and partner with as well as you begin to kind of master and take advantage of some of the technologies that we have out there. This to me is a little bit redundant, but we already know, there's a number of different microprocessors. It doesn't matter if whether or not you're using Microsoft, you could be using Apple or Mac OS, whatever the case may be. You could be using Linux, it doesn't matter. But we know that intelligence has been condensed over time into microcontrollers, and they're getting smaller and smaller and smaller where they fit on a fingertip of our finger, right? That's the most important thing. So here we are. As we begin to talk about Neuton, we have, as I mentioned, an automated machine learning solution. There's zero code along the way. We have built a solution that enables all demographics. So it doesn't matter where you are at in your journey. We believe, and hopefully you'll see in just a minute, that you can certainly take advantage of our platform. And we're fairly efficient as it relates to our implementation. And of course, we believe that we are exceptional when it comes to TinyML, especially as it relates to being able to produce compact models that are extremely accurate, that you don't need to take any additional steps. For some of you experienced guys, where you're building models with TensorFlow, you probably need to use TensorFlow Lite to compress that model. You probably are suffering from accuracy. When you do compress that model, we eliminate all of those various steps where you don't have to do that. As soon as our models are built, they're extremely compact, they are extremely accurate, and you don't need to take or expend any additional labor to make sure that it integrates into the microcontroller or sensor that you may be using. So our solution, we're focused on reducing your time, reducing your costs. And enough is said here. I think I mentioned it significantly in the previous device, where we are not compromising accuracy and we're optimizing size. And again, here is an exceptional, I would say, solution that you guys can all take a look at. And actually, this is not our solution. This is a solution, if I'm not mistaken, it's from Edge Impulse. But our objective is to educate. Our objective is to kind of inform you guys what are the opportunities that are out there. But if you want to learn a little bit more, I believe it's from Edge Impulse. Certainly go to Hackster.io. We have a number of different solutions out there ourselves, which we will demonstrate a little later with Andrew. Let's just say with cardiac arrhythmia, if you're from the healthcare perspective, or from agriculture, looking to identify if whether or not fruit or vegetables will be spoiled. Certainly go take a look at Hackster.io, learn a little bit more about this use case. Our approach, as I mentioned, is a couple of different areas that we want to focus on. We have a zero code solution for everyone. All of our platforms, all of our models are built once in one iteration, so you don't have to go through that iterative process. They always come out compact. They always come out accurate. And then more importantly, from a explainability perspective, we like to say never compromise. Now, depending upon if you're doing TinyML, there may be some limited explainability because the data is coming in raw directly through the sensors. But if you look at our platform in its entirety, not compromising is something that is extremely important, especially when you begin to try to understand what's behind the models that you are producing. I may have mentioned this, but if I haven't, oftentimes we are building our models up to 1,000 times smaller than what you might find. When it comes to inference, this is the speed of predictions, and the physical size of the models as it relates to coefficients and neurons are also extremely smaller. Now, what I like to show you guys is something that we have done on our platform. It is related to being able to predict if whether or not may or may not be susceptible to diabetes. There's a number of different features, such as what's their glucose, blood pressure, how thick is their skin, their insulin, their BMI, their age, etc. And then we'll make a determination on if whether or not someone is susceptible to diabetes. So what I'll do here, I will head over to our platform. So just give me a minute, not even a minute, I will just connect to our platform. So just give me a second. And here we go. I'm not sharing, I stopped sharing. So there's just a second to give me an opportunity to log on to our platform. And again, if you guys have any questions, I have a couple of my colleagues that are on the session. You can certainly take a moment, you can type them in chat, and I hopefully that either Yulia or Roman are answering the questions along the way. And as we get to the end of today's session, or to this particular moment where we have a break, I will certainly then answer any questions that may be allowed. So I will again share my screen. And hopefully, and maybe Yulia, you can just confirm that you can see my screen.
Yeah, we can see your screen with the presentation, but not with the now we can see your platform.
All right. Okay. Excellent. Excellent. Thank you so much.
Mm-hmm.
And this, at least for me, the little box is in my way. I will try to move it. All right. Here we go. All right. So I move this over here. Get rid of this password manager. This is what our platform looks like. So it's a web-based platform. We mentioned that it's zero code. You can see it's tile-based. Each tile is an individual machine learning solution. What I did earlier today is I did train a model. What I'm going to do at the moment is just enable the model while we kind of go through some other steps, okay? So that'll complete in the background, if you don't mind. But let's begin to kind of take a look at our platform. So here, if you want to begin the process as it relates to creating a new solution, you just certainly click on Add New Solution. And one of the things that I want to tell you guys, and my apologies if I didn't bring this up earlier, for those individuals that will be staying throughout our course and going through the training, you will be receiving a certificate at the end of our event. We just need to make sure that we have your email address. So since there is a training session, which one of my colleagues will be doing for you guys, I just wanted to highlight that. And so my apologies if I didn't mention it. But let's go here. I'll type in a name of the description, demo BU, and Friday Fun Day. All right. And I type in next. Now, at this point, you can see we enter into our 3-step pipeline. Now, you have a couple of different options. You can drag and drop your data set. If you like, depending upon your area of focus, if you wanted to, you can go to our preloaded data sets. Our preloaded data sets are available to you just depending upon your sector, depending upon your vertical that you want to focus on. We have a number of different data sets that we make available to you. So you can come here to the preloaded data set and you can take advantage of our platform. You can also then, at least for myself, I have a number of different data sets that I have used before. I could easily come here if I would like and use some of those existing data sets. But what I will do, I will just either drag and drop. And let me see if I can unfortunately clear these notifications that are coming from Slack. My apologies. I will try to kill this thing. And for some reason, I don't see it, but hopefully it'll behave now. Okay. So let me go here. And I can do diabetes training set. Now, if I wanted to, I could view the data set. So here is the number of pregnancies, etc. And then we can see that our target variable, yes or no, is if whether or not we are going to predict that they have diabetes. Their age, their BMI, the amount of insulin they may or may not take. Some individuals take insulin, some don't, you name it. And then I just click OK. Now here, we have to select our target variable. So do they have diabetes? And I can click next. Now guys, at this point, you can 100% just start training. It's up to you. Completely up to you. But I'll show you guys just something really quick. Number one, you can change the metric that you would use from an accuracy perspective. Now, just again, we will default to the metric that we believe is the most efficient. Irrespective as to what metric that you choose, we will report on all of them. So have no fear about that. But we do understand it is a binary classification problem. If this was a TinyML problem, you can click on TinyML. You can highlight if whether or not what bit calculation that you're going to use, and you can make a determination on if whether or not it's going to be 8-bit, is going to be 16-bit, is going to be 32-bit, etc. And we are one of the few vendors that have an opportunity to work on 8-bit. So natively, we can work on 8-bit devices. So if this is an area of focus for yourself, you can certainly take advantage of that. We also support float type. You can select if whether or not floats will be supported. And please, my apologies. I'm sorry. I'm just hoping to kill Slack so that it doesn't keep being disruptive. And then also, depending upon your data set, if it's classification, you can do digital signal processing, etc. If it's not digital signal processing and you're doing binary classification, you can also then select your normalization type. Lastly, just so that you understand our platform, you could easily just go into advanced mode. And if you wanted to, going into advanced mode, there's a couple of different options that you have available to you. You could identify what's the size of the model that you want. If you want to enable feature engineering, it's just a checkbox. And if you were doing time series, this will be a place where you would go into time series. Lastly, when we begin to talk about time series, you would have to enter your date and time column. So in this particular case, we're not using time series. Right? And I'll just click start training. And as it relates to a 2 or 3-step process, that's all that you have to do in order to begin to build a model. We automate everything in the back end. We automate everything from a data preprocessing perspective, and we also automate everything from a feature engineering perspective. And now I just kind of want to be respectful of time as we begin to kind of look at being able to run predictions. I will show and demonstrate to you guys very quickly predictions, and then we'll take a brief break, okay? So here, there's a couple of different things you can see that I enable the predictions. We allow for you to do 3 different types of predictions. You want to do it via the web, you want to do it via the REST API, or if you would like to integrate it into your model, you can do that by doing downloads. You just simply click, select your operating system. From a REST API perspective, depending upon your algorithm, your language of choice, you can also select here, Python, Java, C#, and Scala. But let's just really quick, we'll do a web prediction. And we can see here, we're going to use diabetes test. This does not have the prediction on if whether or not someone will have diabetes. But we click start. And when we click start, we'll be able to see it should go probably in about 10 or 15 seconds. If you want, you can download or you can view. Here we are viewing a prediction. Now at this point, we have the predictions. We give the probability as it relates to 0 or 1. So in this particular case, you can see this individual has a 95% chance of not having diabetes. We also give something what is called the model to data relevance indicator, which is an indication on if whether or not your model is beginning to decay. So we proactively identify and let you guys know that. But let's select this guy. We go into our tool, the model interpreter. Now, when we go into our tool, the model interpreter, we will do something that is extremely amazing and fantastic that literally I find that most, if not all of our customers find extremely valuable. So you can see here, here's the prediction, 90% of 0. Here are all of the values on the left-hand side. But if you would like, you can dynamically change the value of any feature to see how it may influence your prediction. Same here. You can see it starts out 90%, but if I increase their BMI, oh man, it goes down to 50%. It even says now they're going to have diabetes. If I want, I can click on it and see how it impacts that particular prediction. So if you were so desired, you could, if you want, select a value that will help you identify your ideal customer profile that fits a certain scenario that may be valuable to your organization. See, blood pressure. We can see if we go here, it gets lower, and so on and so forth. Pregnancies, you have a higher chance. The more pregnant you are, the more higher you have to have gestational diabetes, as an example. And you can click it. And once you click it, then you can see how it may also impact the other predictions as well. So it's an extremely valuable tool that you can use to help model some of the results that you may be looking for. Now, another thing that I want to highlight to you guys before we begin to wrap up is just two things very quickly. And I want to be cognizant of how long we've been going and the time, so we can take just a quick break. Now, our tool, as I mentioned, we do have a life cycle management tool right here. As this percentage begins to go down, this percentage will give you an indication that your model is beginning to decay. You may also see that the leaves on the tree may turn colors or the leaves may fall off. You can also go here to analytics tools and see the performance feature importance matrix. This will tell you, here are the top 10 features that are influencing predictions. Here are the bottom 10 features. Sometimes you may think that some features are influencing your predictions when they're not, but we give both of those options. And then lastly, if you would like, you can go to the training tab, we go to analytics tools, and we go to our exploratory data analysis tool. It's one of the tools that I mentioned to you that gives you insight as to what your data looks like ahead of time. And we give you a tremendous amount of information, what the data looks like as a whole from an overview perspective. We also provide you some insight as to the distribution of your data. We also handle anomaly detection extremely well. In this particular case, it's only 66 to 34% distribution. So it's not so unbalanced. Well, we give you a heat map as well. So you kind of want to begin to look at which features have the highest correlation to the target variable. And then lastly, as we look at the EDA, we also kind of give you what we call a model quality index. Now, one of the things that you'll see is that I only trained the model for 2 minutes. So take a look. Model trained in 2 minutes. And it's just for the sake, of course, our presentation, we're at 76% accuracy. We trained it in 2 minutes. In 2 minutes, we're at 75% accuracy overall, 76% accuracy overall. And you can also begin to see how small the model is. 21 coefficients, 0.13 kilobytes. Certainly something that you could embed into any physical device that you may be working with. So what I would like to do right now is just begin to highlight some of the areas where we found that whether you're looking at TensorFlow, whether you're looking at TensorFlow Lite, we not only compare from an accuracy perspective, as hopefully you can see, but also you can see that the size of our models are significantly smaller. The number of coefficients, we have 372 coefficients, over 7,000. The amount of RAM that we use, and our inference time. How fast are you going to get those predictions? So what I would like to do right now, I'd like to invite all of you guys, if you haven't already, please go to Neuton.AI/start, and you can sign up to our platform for free. And you'll have it accessible to all of the different functions, all of the different features that we've discussed today. So I believe, if I'm not mistaken, we will roughly take about a 15-minute break. 10 to 15-minute break. And so I encourage you guys to do that. And if you have any questions along the way, we will be here to answer them for you. We will start back up. I believe the time is 9:25. And since we ran a little bit late, and I know maybe you guys, I'm sorry, and on the East Coast, it's probably lunchtime. My apologies for running a little bit late, but I thought the information that I was sharing with you guys was important. We will start back in 15 minutes. So at 12:40 Eastern time, 9:40 West Coast time, we will start back the presentation. But in the meantime, if you guys have any questions, you have any thoughts, etc., whether it's myself or whether it's some of my other colleagues, we'll be happy to answer your questions. And you can answer the request those questions here in chat. We'll answer them verbally or we'll answer them via text, via the chat. So with that said, thank you again, and we will pick up in 15 minutes.
Thank you so much, Blair. Just for all of you who doesn't want to have a lunch and have a questions, I would like to repeat, please, you are very welcome to ask your questions in the chat. So we have here our technical team and we will respond to you. And as well, I would like you to ask some our questions, just 2 of them. I will run now the short poll you will see on the screen, just to understand your background and what topics you would like to study. It will help us also to make our next sessions more practical for you. So please, you are very welcome to answer these questions. Okay, perfect. We see that, we have here professionals who knows a lot about machine learning, embedded systems, and even TinyML. It's great to know it. Yeah, please, you are welcome to answer. Okay. By the way, if you want to have a lunch and have a short break, you are free to do it. We will come back in 15 minutes. But meanwhile, you also can take advantage and ask some of your questions. You can put it on the chat. Okay, please answer the questions of the survey. We will be very grateful to know you better, to know better your background, your goal in terms of technical aspects that you would like to study. Thank you. Anyway, if you already left or someone of you, we will run this survey in the end again. Okay, thank you. So we have some questions in the chat. We will answer you also here in the chat. And one more thing that I would like you to share with us, because later we will go deeper to a TinyML topic, and we will discuss different AI solutions in this field. So the question that is very interesting for all of us, what exactly solutions would you like to see in this world? Maybe you are working on some solutions right now, maybe you have some ideas and you would like to create them and deploy it and create these solutions and run it in the real world. So please put it also on our chat, and we can discuss it during the next session. Okay, we have some questions here. Meanwhile, I will stop the, sorry. So yeah, we will answer you on the chat. Meanwhile, we have a break for everyone. We will have some like offline session with the questions and answers. And in 10 minutes, we will be back. Okay, we will collect all your questions, don't worry. Yeah, be proactive. And of course, you have a time now to go and sign in our platform in order to do with us the practical session, the end-to-end use case. And you can create your own model, and then you will see how to embed this model in the easiest way. So please, you are very welcome to sign in. It's absolutely for free. And if you have some questions or issues of the registration process, just tell us here in chat, we will help you. Mm-hmm. So we will back in a few minutes. Please register, please give us your questions and ideas about AI solutions. See you in a few minutes.
Hello, everyone. I just wanted to kind of take a moment to come back in. So we'll be restarting our event in roughly around 3 minutes. So I'm hopeful that some of you guys have had an opportunity to log into our platform, as well as if you guys have any questions, certainly please feel free to either enter them in the chat or the Q&A, and we'll be happy to answer those questions. Yulia, I just want to make sure that we are geared to start in the next 2 minutes.
I think we need to give a little bit more time for break, maybe 2, 3, 5 minutes. And we have here questions, a lot of questions from, yeah, okay.
Yeah, let's see if I see any questions. I see one, we talk about data privacy policies. So maybe I can answer that question. So from a data privacy policy, we have not found that at any point there's any personal data that is needed to build a model. But you do have a couple of different options. One, obviously, once you build the model, you can then delete your data set, et cetera. But you can either do an anonymization, which is one technique or tool that some of our customers use, or you can use hashed accounts if you are looking to identify individuals depending upon your data set. So those are kind of two options that we give our customers, or not just we give our customers, it's not just us, it's really for any AutoML solution as to the approaches you take as relates to privacy policies. So those are just kind of, I would just say, just standard answers that we, our solutions that we make available. So let's see if there are any other questions that we might see that maybe I can answer. Let's see. I'm not sure if there are any others in the chat. Maybe I can just answer some questions that were asked in the chat. maybe they were not always answered to the entire group. I see that model interpreter allows you to, okay, that was a question. Features manual setting gives better results than AutoML. So I will answer this a bit differently. So I will answer it in a sense that one of the things that we do that makes us very different. So typically, if you're building a model, especially if you're leveraging some of the existing frameworks that are out there, some of the existing frameworks that are out there, one of the things is that you will typically have a fully connected network. Meaning you're connecting to all of the various features. And when you're irrespective of their predictive power. So that means you're connecting to features or data points that may or may not have a impact or significant impact on the predictive power. Now, when you do that, let's just say with TensorFlow, it can produce a material amount of waste because you're including features or connected points that, for all intents and purposes, it has no impact or very minimal impact. Well, our approach, and we'll explain this in just a moment, our approach is very different. We don't start off with an existing structure at all. What we do is we start off with building a model that is fit for purpose every single time. And what I mean by fit for purpose is that we're building that model from the bottom up, neuron by neuron, and we're performing cross-validation along the way. So this means that inherently our models will be smaller. It means that they'll be more accurate because as we add each neuron and we perform cross-validation up to 10 times cross-validation, then at that point, our model is complete and you do not have to perform any compression techniques, whether it's quantization, pruning, etc. This is what allows for us to have an extremely tiny or compact model in our ecosystem. And so I think I'll use that, Yulia, to just kind of talk about the rest of our agenda for today as we kind of get started. So for the rest of our agenda for today, I will share with you guys our approach as it relates to TinyML, because certainly TinyML is an area that we're focused on. We have a number of different partners in this particular area, specifically ARM. And hopefully, maybe you guys have had the opportunity to be introduced to ARM. ARM is an organization that I would probably say most, if not all, but I'll say most, silicon providers are leveraging their IP, their intellectual property. And in addition to this, one of the things that we'll be talking about is how can we make edge devices smarter? And what's our approach as it relates to making edge devices smarter? And then from there, after we have a brief call with discussion with our ARM colleagues, then one of my colleagues, Andrew, he'll be taking you guys through a practical session as it relates to building a model and embedding that model from a TinyML perspective. So hopefully we're in a good position where, again, we're showing you guys the entire life cycle where you can see how everything can take you. So with that,
yeah, Blair, sorry to interrupt you. We had some question also about AutoML, Neuton platform, and so on. So maybe if you don't mind, we can change a little bit our agenda, and you can start with this, answering this question, and then we go to ARM session.
Yeah, I mean, I will answer the question. I think that I saw it. But one of the things that for our platform, and my apologies if I didn't mention this before, but our platform is vendor agnostic. So where you may experience that some platforms will build models that are specifically optimized to a specific set of hardware, that's not our approach that we take. So since we are building all of our models neuron by neuron, and they're coming out natively compact, all of our models are open source. So we will provide for you a C calculator. In addition to that, we can also provide to you a model that is ONNX compliant as well as H5 compliant. I'm not personally familiar with those tools, but I believe that what I mentioned will certainly, I'm hopeful that it's compatible with those specific tools that you mentioned in the Q&A. But we are agnostic and we are not specifically geared to any specific device. So as we move forward now, our approach here is to begin to talk about what are some of the areas or challenges that we have as it relates to TinyML. One of the things that I mentioned is that from a TinyML perspective, as a community, we're looking to see billions of devices enabled from a technology perspective. And we've identified 3 key areas that we believe are limiting this adoption. So number 1 is the availability of resources. Resources are extremely intensive. It's a high level of friction, whether it's their availability and cost, or whether it's just availability from the amount of individuals who have this expertise. And then of course, being able to have the ability to integrate these models into small devices. As we've seen earlier, those devices are getting smaller and smaller, smaller, and of course, cheaper. And then lastly, just depending upon what you are implementing in your ecosystem, you want to make sure that you can understand the quality behind your model. You want to understand what's driving the decisions behind your model, especially if you're completing the entire life cycle and you're implementing those models into production. Those are all of the areas, or some of the areas, we believe are the primary areas that are limiting the adoption. But some of the things that I like to challenge all of you guys to think about, irrespective as to where you may be in your journey as a professional or individually, would it be important to you if you can build a model without any technical expertise? These are one of the questions I would want to ask yourself, or maybe your organization. If you can do it in 3 clicks, 3 steps in a workflow. What about if you can find a model in 1 iteration? Today, if you're using other frameworks, you're doing this in multiple iterations. Especially if you're in a TinyML space. What about if you can build a model up to 1,000 times smaller than what you might find with TensorFlow or TensorFlow-like? Run inferences or your predictions 60 times faster. If you're into algo trading, how important is it that you submit that particular trade? How much money does it cost you? Eliminate the need for compression and not compromise accuracy. This is something we talked about already, extremely extensively. But again, it's one thing to be able to produce something, but do you know it's accurate? Do you know it's producing you the results? Do you know if whether or not your model is beginning to decay? So explainability is important. And then of course, accelerating your time to market. This is something that we believe is extremely important, whether it's going through your hypothesis, whether it's going through whether or not reaching production. And lastly, as we said, we encourage all of you guys, it's our model to build fast, build once, and not compromise. More importantly, not only in accuracy, but also in your business requirements. And these are all of the questions that we challenge and we ask all of you guys. When you pick a tool, can they check the box on all of these specific topics? Here's something that we've talked about. Here's how things look today. If you're building models today, this is what you encounter. You're looking to identify your business requirements. You're identifying your hardware. You're going through the process of which model, which framework, which algorithm am I going to use? And irrespective of which model, which algorithm, which framework that you're going to use, you're going to need to, more often than not, compress that model so that it can integrate into your edge device. And that means you need to go through compression. Are you going to do distalization? Are you going to do quantization? Are you going to do pruning and compromise accuracy? And then, of course, you need to figure out, okay, once I do that, how I'm going to embed the model. And then, does the accuracy meet your business requirements? If it doesn't, guess what? You're going to start over. It's typically a very iterative process. And all of the guys, I think we have a couple of our team members that are in the chat today, some of our data scientists, Andre, Rahman, et cetera. You can talk to them. They've been building models with and without Neuton, and certainly certain they can share with you some of their experiences. Because lastly, in the end, can you trust that model? Can you put it into production? It's 100% manual efforts, and typically it takes a number of different months for you to accomplish this. This is, again, where I raise the question. You know, my objective is, do I want to be a mechanic or am I focused on results? For me, from a business perspective, doesn't matter if I'm technical, doesn't matter if I'm an executive, it doesn't matter. I'm looking for results from our organization, and that's what we encourage you to do as well. So what's next? We want to show you guys how you can do it. More importantly, how we do it as it relates to being able to build models without compromising accuracy and can integrate into any respective model or device, any respective device without compromising accuracy. Take a look.
How does Neuton create incredibly compact and accurate models? First, Neuton uses a selective approach to the connected features. Let us take as an example, the model for determining cardiac arrhythmias. Amplitude of contraction of the heart muscle acts as one of the features for training the model. As you can see, Neuton only needed to make connections with half of the features. We also leverage a unique patented algorithm to adjust the coefficients within a model. Unlike most algorithms, Neuton's algorithm is not based on backward propagation of errors and the stochastic gradient descent. Furthermore, the Neuton algorithm is minimizing the likelihood of hitting local minima. This is especially important when building small models. You can see that in our example we've achieved an area under the curve value of 0.96 with only 253 coefficients. Meanwhile, achieving the same accuracy with TensorFlow requires significantly more coefficients. Neuton is even 10 times smaller than TensorFlow Lite. The Neuton platform enables models to be built automatically, neuron by neuron, starting from learning general features and moving toward identifying the most specific ones. This allows selection of a model of almost any level of precision and size, in a single iteration. The Neuton eliminates the time-consuming multidimensional manual search for network parameters including number of layers, neurons, type of activation function, batch size, dropout, learning rate, and more efficiently finds the optimal structure. The neuron-by-neuron growth makes it possible for cross-validation to occur progressively, which is typically not feasible with a standard approach. The combination of these characteristics also increases the generalizing capabilities of the model, which allows for creation of compact models, without compromising accuracy.
So hopefully all of you guys have found that informative, but I kind of want to highlight a couple of different things that I thought were important as it relates to this presentation. When you begin to kind of take a look at TinyML, and you are looking to integrate your models into MCUs or sensors, etc. One of the more important things are what I like to say, what is your currency? What is the value in this particular implementation? And it boils down to two things. It's space and power. How much space are you consuming? And how much power are you consuming? Without that, your implementation is questionable. And these are the two areas that as an organization we focus on. As we begin to look at the exponential growth of TinyML, and we certainly encourage all of you guys to do the same. These are two of the areas that I certainly ask for you guys to take into consideration and for you guys to value along the way. So in summary, some of the areas that we're focused on as it relates to how does it enable us to achieve some of the things that I've mentioned to you. How are we 1,000 times smaller than PyTorch, Keras, TensorFlow? And when you begin to look at TensorFlow Lite, also much more efficient. One of the things that I highlighted is that we don't start off with connected networks. Nevertheless, we only identify the features that are most important or have the highest predictive capability. Then we start not from a top-down approach, but from a bottom-up approach as it relates to growing all of our networks, networks, neuron by neuron. We don't use NAS or anything like that. We do have our own algorithm as it relates to building the models. But even though we're leveraging our own algorithm as it relates to building the models, all of our models are extremely open. They're 100% open. It's one of the things that I mentioned earlier. So whether you're using Onyx, whether you're using H5 format, so you can integrate with Keras, etc., you can still leverage our platform. So in building, we use our unique technology to give you the most optimal results. In the end, you're able to implement it anywhere at any time on any device. Now, here's something that I've certainly mentioned before, and I apologize because sometimes I get a little bit ahead of myself, but you may have seen that our models, our algorithms, it's not based upon backpropagation. Our models, depending upon where you're looking to implement them, we can use a high potential for parallelizing. So if you want to use multiple GPUs, etc. We do permanent cross-validation, but also more importantly, even though we're growing our network neuron by neuron, we have a built-in overfitting control. So no overfitting will you experience, or limited overfitting will you experience as it relates to our platform. Something that we're not, let's just say, vulnerable to. And then lastly, one of the things that I like to highlight, especially when you begin to think about the iterative process that you would typically go through. We don't typically run into any local minimums, any local extremes or plateaus, but we handle this all in the background for you automatically. Again, we're focused on producing the result so that you can bring value to your organization. That's our focus. And when it comes to integration, we have the ability to be device agnostic, and we can integrate with devices who may have less than 100 kilobytes. I think you guys could have seen that in one of our examples. It was 0.13 kilobytes, the models that we're producing. So certainly the adaptability and the usability of our models are extremely high. Now, this is something that you may experience today, especially for some of the more experienced individuals that are out there. So you're looking to build a model, leveraging TensorFlow as an example. You have to go through a number of different steps as it relates to building a model, very iterative. And then you're going to go through compression with TensorFlow Lite. And I mentioned before, you're going to be vulnerable to reduce, let's just say, accuracy. Then you have to take those steps as it relates to embedding your model into a microcontroller. We eliminate all of those iterative steps, and we allow for you guys to build a model in one step, and then you can proceed to embed it into a microcontroller, which one of my colleagues will show with you guys today. So we're going to take you through the entire life cycle, including embedding into a microcontroller shortly thereafter. Now, here we have another example where we're talking about being able to detect if whether or not someone may or may not be prone to a stroke or heart attack, specifically cardiac arrhythmia. 1 second, and hopefully I can, oh, maybe I have a problem with this particular one and we will not proceed with this. So my apologies, for some reason, it seems like my Outlook is not working and I cannot show you guys the use case for embedded into a microcontroller as it relates to cardiac arrhythmia, but hopefully we'll be able to show you guys this a little bit later. So please accept my apologies. So where we are today. So when you kind of begin to look at today, what you're doing when you're building a model, it's a very manual process, whether it's, including the learning rate, the number of cross validations, dropouts, thinking about the different activation functions you're going to leverage. We eliminate all of that. You're also typically starting out with a pre-existing structure, whether it's stochastic gradient descent, whether it's back propagation. We eliminate all of those various steps that you have to consider in building your neural networks today. As I mentioned, not to be redundant, that we optimize building our models neuron by neuron at each iteration. We're able to build models so that you guys can implement these models into your devices of choice without compromising accuracy. More importantly, when you begin to think about the ease of use, that's something else that I certainly want to be able to highlight to you guys. But what's next? You've built a model. You're ready to implement it in production. How do you know that that model is ready to be implemented into production? How do you know your organization is going to get the results that it's expecting? Well, we have an explainability office for you guys that allows for you to understand this pre and post production. And I always like to challenge all of you guys. Ask yourselves these 4 questions, irrespective as to which tool that you're using. It doesn't matter. You could be using our tool, you can be using another tool, but it's a question, or I believe 4 questions that all of you guys should answer. And if you can't answer these questions leveraging the tool that you have in mind, then maybe you should reconsider. Do you know what your data consists of? That's number 1. You should know that before you produce a model. What are the most important features? How do you know the features that you've included in your data set will actually help you or enable your predictions? Then number 3, which I like to believe to be most important, why does your model make those predictions? Do you have that transparency? Are you able to understand how each individual feature or variable is influencing your prediction? Do you understand if your model has bias? Does your data have bias? These are some of the things that we help you answer. And then lastly, from a lifecycle management perspective, hey, how do you know when your model is beginning to decay? It's old, it's doing erroneous predictions. Do you wait to have erroneous results? Do you wait so that maybe you guys are making business decisions that are inaccurate? We proactively let you know that your model should be retrained. These are questions that you should understand irrespective as to what tool that you use. And I challenge and I encourage you guys to understand this and to know this moving forward. Now, in our case, we provide all of you guys this insight. And that's something that from an organizational perspective, I'm extremely proud of. So now, when you kind of begin to think about some of the questions I asked you earlier, think about the tools, if this is where you're at in your journey. How many of them can check the box? How many of them can help you accelerate your time to market? How many of them can help you build a model in 3 clicks without any technical expertise? Run inferences 60% faster. All of those things, are they important to you? I hope so, and I believe so. Now, as we begin to summarize, and before I hand it off to Yulia, who will begin to introduce ARM, I'd like to encourage you guys to think about some of our key tenets. some of the key areas that we find extremely important. Can you build fast? Build fast doesn't mean Russian. In this case, it means efficient. Are you able to do it with the right resources, at the right time, at the right pace, at the right cost? Build once. Do you want to go through 10 iterations, 15 iterations? And then even if you are successful, can you even integrate that model into the device that you're working with? And then lastly, how many of us is up to compromise? Do we want to accept less than what's available to us? Whether it's explainability, whether it's accuracy, whether it's the size of the model. I encourage and continue to ask and challenge you guys to keep this in mind. And this is an area, undoubtedly, that we believe that we can continue to focus and help you guys with. Now, for today, we really wanted to have an opportunity to give you guys a complete arc, whether you are beginning, whether you're in the middle, whether you're just smack dead in the middle of working on the project. We wanted to give you guys a complete perspective, and not just our perspective. We also wanted to share with you guys a perspective as it relates to ARM. Some of you guys, I hope, are familiar with ARM as an organization. And if you're not, you can use this as an opportunity to learn more about them. Because more often than not, if you're leveraging a microcontroller, if you're leveraging a sensor or any small, tiny device, it's a pretty good chance you're using their technology. Doesn't matter who the manufacturer are. More often than not, their IP is being used from an ARM perspective. So I would like to extend my thanks to all of you guys to giving me the opportunity to share with you guys this morning, especially on a Friday, and share with you guys some of the insights and direction that we believe that TinyML, our machine learning, is taking in today's age. And lastly, what's our view? So we're profoundly thanks for you guys joining us today. And as I mentioned earlier, we'll be extremely happy to continue to answer any questions that you guys might have as we progress throughout today's event. So with that said, I'm gonna hand it over to my colleague, Yulia, who will continue engaging us throughout the day and introduce the next two sections. So thank you guys very much, and I appreciate all of your time and engagement today. Thank you.
Well, thank you so much, Blair. It was a wonderful session. I hope it was very interesting for all our attendees today. And yes, let me be short because we're a little bit out of the time. So I would like just to jump to the next session where our partner and the biggest leader in this, of this industry, ARM, will show you their view of the current situation of the trends in this industry, and also will share with you guys opportunities for you how to join this global AI community and ecosystem. Unfortunately, Tobias from ARM couldn't be today with us physically, but he will absolutely happy to answer all your questions. After his keynote, I will share his LinkedIn profile so you can connect him and address their question. I don't know if it's some problems with the sound. Let me share my screen, and please confirm if you can also see it and if the sound is good. Ilya, if you see that the sound is not good, please let me know. I will start right now. Let me know if you can see it. Okay. right now.
And I want to spend a bit of time with you today talking about ARM and how together with our ecosystem, we are enabling this endpoint ML revolution. And as I said, although I can't be with you in person today, please do reach out to me if you've got any questions or you want to find out a bit more. So let's delve in. Let's find out a bit more about how we're enabling the endpoint ML revolution. I want to start off by talking a bit more about ARM. ARM's the world's leading semiconductor IP supplier, intellectual property for short. And our purpose is to spark the world's potential, from the tiniest of sensors to more than 99% of all smartphones, the cutting edge of automotive design, the largest cloud data centers, and the most powerful supercomputers. Our energy efficient processor designs and software platforms have enabled advanced computing in more than 200 billion chips. That's an incredible number. And our technologies securely power products right from the sensor to the smartphone and to the supercomputer. And together with over 1,000 technology partners, we are at the forefront of designing, securing, and managing all areas of AI-enhanced compute, right from the chip all the way up to the cloud. It's really phenomenal. I'd like to take a moment and switch away from ARM for a second and look at machine learning. I want to look at how we got here with machine learning, because AI and specifically machine learning really kicked off in hyperscale data centers. Why, you ask? Well, that's where the big example data sets were. And as we all know, when it comes to machine learning, the most important computational problem that faces the world today is identifying pictures of cats. And if you want to identify pictures containing cats, then you need billions of annotated pictures, of cats to train your ML models. And I mentioned training here specifically and deliberately because it's important, as you know, to distinguish this from the inference side of things. They're completely separate compute problems and have very separate deployment requirements. Training models requires massive storage and vast runtimes, as well as vast compute. Now, historically, the cloud and the hyperscale data centers is where most people experiment, design, and discover new neural networks. It's there today, and it's probably going to stay that way for a while. But if you want to train models, doing it near the example data sets makes a world of sense. But the center of gravity is rapidly expanding to the endpoint device. Why? Well, that's where the input data is. That's the data you want to process and test when you use those models for inference. Now, that means developing ML models that work well on the tiniest of devices. Small, low-power processors optimized to run those models are needed. Now, training might well occur in the cloud, although there are steps to do more training on devices, but today the bulk of inference happens on the endpoint. And this inference occurs across a wide variety of use cases that we at ARM break down into what we call the 3 Vs: voice, vision, and vibration. And these happen across these endpoint ML applications and others. Aside from being where the data is, there are other reasons that AI is moving to the edge, and I want to expand on this a bit more. Start off with bandwidth. Shifting huge amounts of data back and forth from the cloud to process and then back into an application, that could produce a noticeable lag or delay, and that can be annoying to the user. And it's not just about a better user experience though, right? It's the cost of shifting and storing that data. It's vast. I don't know, think about the number of HD cameras that are installed that are connected. The cloud can't take all of that HD video that users are taking and sending over the network. And given the increases in the number of cameras, the problem's only going to get worse. The internet would simply break. Let's look at something else though. Let's look at power next. It takes a significant amount of power to transmit all that data. Building more data centers and server farms, that's not the answer to the ever-increasing data handling. Enormous power consumption is needed to enable that to work. And that power costs money, and it's detrimental to our carbon footprint. And that's an increasing area of focus for many cloud service providers and, of course, consumers. Now, in simple terms, a given amount of compute takes less power on edge devices than in data centers. Let's look at cost next. The cost of transmitting data is significant. It's cheaper to do the computation on edge devices rather than in the cloud on servers, and someone else is paying for that cost of computation. So the cost of transmitting data is really significant. And it's not just us who are noticing all the challenges of doing the computation on the edge device, doing the computation on the cloud versus the edge device. Google realized that if every Android user in the world used about 3 minutes of voice recognition time a day, Google would need twice as much computing power to handle it all. I.e., the world's largest computing infrastructure have to double in size. Just boggles the mind. Latency. Time-critical applications like automotive, they just can't rely on connectivity in the cloud sometimes. You've got to run some activity locally on device. And in this case, the device is a vehicle. But you see the more general point, right? The capabilities, they're needed at the edge. And that relates nicely to reliability. We've all experienced times when our mobile phone or cell phone, I guess as you Americans call them, it loses its signal. When the internet just seems to stop working, right? Frustrating. So local on-device processing is needed to keep those applications, those ML applications, processing at their fastest speeds and those fastest speeds reliably. Security and privacy. This is a big focus. You know, I don't need to be I'm sure I'm preaching to the converted here in saying that recent events over the last few years, they're really bringing security to the forefront of users' minds, and they're demanding it by right. ML is, of course, enabling security measures on your device. So some Android phones can now tell who you are by your gait, by the way you walk, and they can lock the phone if the walk is determined not to be your owner's. Tied closely to that, of course, is privacy. Nobody wants their data breached, and the risk of that increases when it's constantly moving back and forth from the cloud to the device. Users are increasingly demanding privacy, controlling that data, particularly when that data is personal and sensitive. And that's often the case for using ML models. So the protection of that data is increasingly being mandated by law. So in summary, AI on the edge, it's more responsive, more reliable, more secure, and the data is better protected because it doesn't leave the device. This is all behind TinyML and Endpoint ML. So let's bring that focus back to ARM. Started with ARM, talked a bit about machine learning, let's bring the two together. What about ARM and AI? ARM is a world leader in AI. We've got powerful, scalable processors across our CPUs, our GPUs, and dedicated neural processing units, NPUs, designed specifically for acceleration from ML. And we've got software, tools, standards, and support needed to make AI sing. And combine that with our diverse ecosystem, ARM and our partners are sparking the world's AI potential. ARM AI really is everywhere. It really is everywhere. For ARM and ML innovation, in each of these segments that we service, whether it's IoT, mobile, home, the server, automotive, or others, it's not a one-size-fits-all approach that we take. These general purpose processors that used to suit most needs for desktop computers or car electronics, that was the case, but today ARM's partners' needs for efficient processing have changed drastically. They've been doubling every couple of years, and they are accelerating even faster. Now AI is driving an insatiable demand for compute. We need specialist processing. Our partners who are building modern SoCs need to configure different specialized processing elements to match those needs. So only ARM's investing to meet those needs for a range of processing IP, from the lowest cost devices right up to supercomputers. And with AI moving to the edge, this need for specialized processing can't be overstated. And that's why the combination of ARM's CPUs and NPUs and GPUs, together with being the software framework of choice for edge devices, is helping drive that inference right to the edge. It's accelerating AI compute, helping our ecosystem harness the endpoint ML revolution. So ARM and AI are synonymous with each other. And we've got special purpose-built specialized processing across the use cases. And we've got this purpose-built design and AI expertise that can be seen across the world of endpoint AI. Of course, different computing problems need that different mix of computing components, as I mentioned. And if we focus on something like IoT devices, many of those need to interpret their worlds. So if we combine our Cortex-M cores with something else, our ethos line, which I'll touch on in a second, well, that's perfect for the world of endpoint ML and TinyML. The Cortex-M has that flexibility. It's got that ubiquitous presence and features such as our new helium extensions in the architecture. And these provide the foundation for these embedded systems. But dedicated ML accelerators like the Ethos U55 and the Ethos U65 from ARM take the possibilities to the next level. These are a new class of ML processor that we call a micro NPU. And they're specifically designed to accelerate ML inference in area-constrained embedded devices. They're designed to work in tandem with a Cortex-M, and in the case of a U65, a Cortex-A as well, and easily integrate into existing designs. But they provide a huge increase in neural network performance because they're designed specifically for this task. They are an ML accelerator. They accelerate neural networks. But we've also got at ARM a common software development environment. So that makes your development and deployment easy and takes maximum advantage of the system's power and its flexibility. I mentioned about that specialized processing approach that we've designed to enable this next generation of on-device endpoint ML. Let's give an example, see some data. When you look at a typical ML workload for a voice assistant, our latest generation Cortex M55 alone already provides a 6x speed up in inference times and a 7x increase in energy efficiency. But when you combine that CPU with a dedicated micro NPU, here our Ethos U55, the results are just astonishing. You see typically a 50, that's 50x speed up in inference, and anywhere from a 25 to 75 times improvement in energy efficiency. That's just astounding numbers. Again, 50 times speed up in inference, nearly up to 75 times improvement in energy efficiency. And they give you a glimpse as to where the future of endpoint ML is heading. It's really, really exciting. But ARM's strength lies not only in our powerful, scalable processors and end-to-end software solution. When you combine that with an ecosystem, you really see how ARM's going to enable the next generation of AI. For instance, we've got an ARM AI partner program, which Neuton is one of our members. ARM AI partners provide a wide range of hardware and software solutions for developers to easily prototype and produce AI devices. And we support our partners through a variety of technical support, resources, co-marketing, and event opportunities. So we've got an extensive AI ecosystem which simplifies AI deployment on intelligent endpoint devices by providing the best-in-class tools, algorithms, and applications worldwide. And we're really thrilled Neuton's part of this program, and I suggest you go and check them out and loads of other partners as well, because they may well be interesting to you. They are right at the cutting edge of AI, and visit our catalog. If you head to www.arm.com/AI-catalog, the link is at the top left there, and you can find our market for AI solutions delivered by the ecosystem. You can find AI specialists by use cases and industry and so much more in the IP they support. So you can find them, find out more about the AI solutions and contact them, get in touch with them and see how you can use them. It's really incredible. So I'm personally, as you can probably tell, but the team are also really excited about the possibilities ahead because there'll be a huge wave of next generation AI that will be conceptualized, developed and deployed because of this catalog and because of our partners. So we also work really, really hard to make sure deployment of AI on ARM is simple, whether it's the great documentation we have, how-to guides, workshops, and much more. You can find all of these on our developer.arm.com website, as well as a whole bunch more across the market verticals, across the industries. So do check those out. We've got a variety of YouTube videos, variety of how-to guides, documentation, and more. Just head to developer.arm.com, check out the AI and machine learning pages, and have a browse. But we also want to look at other opportunities here for you. And so we have a great co-marketing avenue we do with our partners, but actually for you guys, it's a fantastic opportunity to have a crash course in machine learning and take your understanding to the next level, because these will be real world applications. We want to show you real world applications, and these come from our ARM AI Tech Talk series. This is a fortnightly series of talks, and they're all about the latest in AI trends, technologies, and best practices. They're really great fun. They're interactive. We've got live demos, workshops, speakers from ARM and the ecosystem. Blair from Neuton gave an awesome presentation in September last year, actually. So you can check that out on the ARM Software Developer YouTube channel. We've got a ton of topics presented here. Blair talked about how Neuton makes neural networks, I think it was 1,000 times smaller and faster. That was just awesome to host. We also look a lot around TinyML and endpoint.ML, of course, in this series. We look at topics like AI bias, robotics, sustainability, spatial AI, key frameworks like TensorFlow Lite, PyTorch, AutoML, all that great stuff. In fact, next week, we've got a talk from ARM ML Research, talking about federated learning. So do check that one out as well. Head to arm.com/tech talks. And you'll hear about the latest and greatest, not just from our ecosystem, but from ARM speakers as well. And there's about 35 talks already on YouTube that you can go and watch. They're anywhere from 30 minutes to an hour long. They're from companies in our ecosystem and from ARM, and they provide you a great opportunity to hear about the latest and greatest that's happening in the ARM ecosystem and in the world of AI. It's really, really exciting. So if you want to find out how ARM's enabling the endpoint ML revolution, our tech talks are the place to be. Please go and check those out. Register and subscribe as you need to. We look forward to seeing you at future tech talks. So as I said, if you're interested, head along to our tech talks. Great education, great opportunity. We've had many, including Neuton, attend and promote at these talks, and it's been and actually present at these talks. It's been phenomenal. I hope that talk's been useful and insightful. If you've got any questions, please reach out to me and do connect with me. I'm happy to answer any questions. As I say, the best opportunities you've got ahead of you are the ones that you can make yourself. And one of the ones you can make yourself is just going out there, checking out our Tech Talk series. It's a great opportunity to hear about the latest in AI. And that's not just me saying it because I work from ARM. I didn't come from a data science, machine learning developer background. I learned a hell of a lot by listening and engaging and actually hosting and moderating these talks. So do check them out. They're really engaging, very approachable. Please do check them out. And as I say, reach out to me if you've got any questions. But it's been an absolute pleasure talking with you today. Sorry I can't be there in person presenting. Other commitments have prevented that. But hopefully in this world of moving to an endemic virus, we can travel a bit more, and actually I can get to meet some of you in person one day. Look forward to connecting with you soon. Stay safe, stay healthy, and I hope you enjoyed that talk on how ARM is enabling the endpoint ML revolution. Thanks very much, everyone.
Thank you. Thank you so much, Tobias. So I hope it was very insightful, actually, for you. And I would like to invite our next speaker here, Andrew. Andrew, please let us know if you can hear us.
Yep. Hey, everyone.
Hello, Andrew. So Andrew will give the last, but maybe one of the most important part of our webinar today, because we, as we promised, we would like to give you very practical knowledge. And in this third part, we would like to show you end-to-end process, how actually you can train the model, create the model, and embed this model, and to create a final AI solution in few clicks. So please, Andrew, could you maybe say some short intro? And I think we would like to jump to a practical session as soon as possible.
Yeah, absolutely. First of all, thank you so much, Boston University, for having us. Also, I thought it was great for Blair to kind of tee us up with kind of, what is AI and ML and kind of where we're going with that. And it was also great to hear from Tobias from ARM as well. My name is Andrew Glutt. I am the Director of Partnerships here at Neuton.AI. And today I'd like to wrap up our session, as Yulia mentioned, with practical use case of how we can start from building a model all the way to the deployment on an end device or microcontroller. As we all know, there has been a disruption in supply chain, whether it comes from, silicon, whether it's, consumer goods, agriculture, or even vaccines. When we look at the supply chain, there's a lot of different opportunities to leverage these, endpoint devices or IoT devices and merge them with artificial intelligence or machine learning. So today, we're going to be looking at predicting whether food is spoiled. And so this will be looking at taking a sensor that will be able to, if you will, smell different gases, and then based on the different level of those gases, will indicate whether the food is spoiled or not. And as we look at this, if we can predict if food will be spoiled in the near future, then what are the actions that we can take specifically to prevent that food spoilage, or to prevent, the vaccines from taking too much vibrations or not fitting within temperature threshold. So overall, we'll just be looking at how we can do this from a step-by-step process. And I saw a lot of you were able to register and get into the Neuton platform. If the URL didn't work, here's a QR code for you. Feel free to pull that up. And what we're going to be doing today is picking one of the AI models that we build in the Neuton platform, and we will be deploying it on an Arduino device. And this particular device is an 8-bit MCU, which means it's very compact and consumes less energy, and will make it very advantageous to leverage the Neuton models, as they're very small, to be able to deploy into an 8-bit microcontroller, in which some of the other frameworks might not be able to achieve this. So hopefully all of you have been able to get into the platform, and we can kind of do this step by step, if you will. And so what we're going to do is kind of look at what Blair showed us today. So we're going to create a new solution, and this is going to be the food quality. And in this case, you can go ahead and pull from the preloaded data sets. In this case, we're pulling it from our computer. And once we've uploaded that or selected it, we'll just hit OK, and then we'll select label as the target variable, which is going to be spoiled or not spoiled. Now we're going to be enabling the TinyML feature and removing float data type support. And now we're going to train the model. So right now, this is a binary classification. And once the training is complete, we'll be able to take a look at the model quality as well as the size of the model here at the bottom of the screen. And next, we will click download. This will allow you to download the model that the Neuton platform has created. In this case, there's only 27 coefficients. And then once we've downloaded the model, next, we will want to go to the GitHub repository, to this link here, and we will download the zip file. And so within this project, and of course, we'll be providing the recording of this. So if you can't get access to the links, etc., if you can do this after the event or on the weekend if you want, we'll be able to provide all of the links and everything like that. And so this project will be taking code for receiving the data set via USB serial port for the device. We'll then be making predictions, getting visual results from the microcontroller, and then code for measuring the prediction time and inference times. So now what you can do is copy and paste the model.c into the project. And then once you've done that, you'll want to compile the project and upload the firmware to the board. So if you go to the Arduino link here, download that, and then connect the Arduino board to your PC via the USB cable. If you don't have access to the device, Arduino also has a lot of very affordable chipsets as well. If for some reason you don't have the financial capability, please just reach out to us directly as well, and we'll see if we can help. And then once you've done that, then you'll open the file from the project. Once you do that, you'll want to click verify, the button for compilation, and then click the upload button to upload the compiled firmware to the MCU via the USB. And once that is complete, next we'll want to perform the prediction. So you'll go ahead and go back to the GitHub repository for the dataset uploader that you can see here. And then depending on your operating system, Mac or Linux, you'll use the appropriate bin file here. The fourth step for performing the prediction, you'll need to specify two parameters. One is the dataset file, and then the second is the USB port. And here within the terminal, we've provided what you'll need to put in the console. And then the utility will read that CSV file and then send samples line by line to the microcontroller. So this is simulating the different gases that would be inputted into the microcontroller that it would be smelling in order to determine whether the food is spoiled or not. And then we'll see some of the resulting prediction times and how much memory was consumed. So in this particular case, we will now send that information to the microcontrollers. As you can see on the bottom, you can see that the LED light is red, meaning that we have predicted that the food is spoiled. And then in the next example, we'll emulate that sensor data. And in this case, we can see that the model predicted 0 class or not spoiled with 100% probability, which means the food is still fresh. And you can see that on the green light here. Here's just a little bit of information about the model parameters based on some of these different metrics like firmware size, RAM usage, inference times, etc., which is extremely fast. And yeah, so that's kind of the step-by-step process to be able to build the model, download it, and then deploy it onto a device. And so I do see some chats here, so let's take a look. Okay, looks like Yulia was just helping out with some different links and things like that. Yeah, so for everyone who joined late, feel free to hop on our Slack channel, follow us on LinkedIn as well. And yeah, once again, thank you everyone for joining us today. I'll throw my LinkedIn link in there as well if you'd like to connect. I'm always happy to talk about technology, business, whatever it may be, and appreciate you all taking the time today.
Yeah, thank you so much, Andrew. We are very apologize about we skipped the second break, because we were a little bit out of the time. So just to save your time, save your attention. But I hope that you really enjoyed the session. As we promised, all that you saw during this session, we will provide by email in our Slack channel, in our YouTube channel. You can see the records and all instructions and also links, because we really want you to repeat this project, to do it by yourself. And it's absolutely a real project. By the way, there is a company who do and who implemented this AI solution in order to improve agriculture processes. So you can do the same just to practice, and it's not difficult. If you saw it, it's just the 5 steps. So we're absolutely sure that you can repeat this project, and we will be very happy to help you with this. So please join our Slack community, because you can connect our technical team and ask any questions that you have, any doubts, any issues during your project. You can ask us, and afterwards, when you've done, it will be your project in your portfolio, and I hope that it will help in your future career, and also it will be maybe first for one of you, or maybe one of the step of the career. So I think now we can have a short Q&A session, and we are very open for all of your questions in the chat and in Q&A. Please be free, be proactive, because if you have some doubts or questions, it's a very good moment to ask us. And please go ahead.
Yeah, and Yulia, while we're waiting for some of the Q&A to come in, there was one question that I thought I would highlight. It was regarding, what does it mean, ML or machine learning on the edge? Does this mean training the models on the edge, or are you training on the cloud? And does Neuton train on the end device, the models, or on the cloud? So I just thought I would kind of clarify it. So when we're listening to Tobias in the context in which he was explaining machine learning on the edge, this was already a trained model that would be deployed in a car sensor, for example, right? He had mentioned, there may be connectivity issues. So, you want to have those models already prepared, pre-trained and deployed so that they're functioning in case there's, an internet connection issue. And then all of the models that Neuton trains is on Google Cloud Platform and on Google Cloud infrastructure as well. So just thought I would kind of highlight that as well. Also, there was a question, does this model also work on Arduino UNO board? So Peter will be answering that in the text here in a few as well.
Okay, let me check if we have more questions. Please be free to ask us. Okay, this question already answered. Perfect. So yes, we also would like to invite you not only to complete the project, but as I mentioned before, to share your ideas, because as Blair mentioned in his keynote, that the future of AI depends on you, of what type of solutions would you like to create, and what type of solutions we will see in the near future depends on you. And from our part, we would like to give your all tools that you need, all knowledge that you need, all support that we can. So please, I just shared in chat our Slack channel. We have global AI community, and you can not only ask us questions, but also make a network, you know, to even to find the internship opportunities and so on. And as we promised also for all of you guys who were with us today, this morning, thank you so much, or maybe for someone it's evening or day, thank you so much. And as we promised, we will send you a certificate of attending this practical session with this webinar. So you will receive it on your email. If you don't receive it, please contact me. I will also share my contact here in the chat, or you can just email us directly. So please, yeah, I think we have one more question in Q&A. So could you please, Andrew, take this question?
Sure. So the question is, should we need to quantize model to work on FPGA boards like Xilinx? And then there's a couple of details there on the device specific. We can have Peter go ahead and answer that specific question. But I believe you will not need to do that if you are leveraging the platform. But Peter, if you want to go ahead and take that one, that would be perfect.
I'm not sure. Is Peter still on? I can answer if he's not still on. But
yep.
So there's no quantization that's required, no pruning, etc. So no compression techniques are required for FPGA, or if you use an ASIC as well. So if you want to pre-embed the model while you're building out the chip, that's something that's available to you as well. So no compression techniques are ever used with our models.
Perfect. Thanks, Blair. All right, we've got another one.
Yeah.
So what is the role of TinyML in real time, but less memory restricted applications like finance? How do the specific goals change as we look ahead to a number of use cases across several fields? Blair, do you maybe want to take this question?
Yeah, can you just repeat the question real quick? I think I got part of it, I'm sorry.
Yeah, I think the general question is more, what's the role of TinyML in applications that aren't restricted for fields like finance, for example, where maybe there's not a sensor, and how do the specific goals change as we look ahead to a number of use cases across several fields?
Yeah, so I think for us, or for me, when I began to think about TinyML, is more importantly just being able to produce a predictive model that is memory and power efficient. So that could mean in a sensor, it can mean an MCU, it can also mean in a smart device, right? So, but when, at least for me, when I began to think about TinyML, is what is the most efficient model you can produce? Because in the end, power consumption is currency. So it doesn't really matter like what's your physical device. If you have a predictive model that is, let's just say, draining your device and your customers can only use it for a short period of time, is really not inefficient, or at least from a customer satisfaction perspective, you won't get the results. But what we've seen, or what I see, is that TinyML is spanning across multiple verticals, and those verticals are, not just limited to whether it's finance. It could be healthcare, it could be agriculture, it can be IoT. So we're seeing that there's a number of different applications, but more importantly, it's the size of the models and it's the efficiency of the models that I think is what we're all looking at to be more efficient.
Yeah, it makes sense. And it kind of makes me think of, doing different types of predictions where you've got, say, like the New York Stock Exchange, and then the data centers who are trying to process them, trying to be locally close. So I'm just wondering, if inference times for like real-time predictions, if those milliseconds in difference could make a financial impact, I'd be curious to understand that.
Yeah, just as an example, just look up algorithms. So algorithms, I mean, everybody has kind of like their own opinion as to how efficient they are let's just say effective. But the expectation or the belief is that algorithms are significantly more faster than any trader can perform on their own, even if you're using something that's online. So look up algorithms, and this was something that was in our presentation. Look up algorithms and look at the efficientness of algorithms. And the expectation and the belief is that these algorithms are able to execute on trades much more efficiently than a human can, or let's just say an application can. So it's something to look up that I think a lot of people would find of interest.
Awesome, great, yeah.
Okay, more questions? As I see, we don't have more questions by now. So anyway, guys, as I mentioned, we are always welcome to all your doubts and questions, and you can connect us directly. And I would like to say thank you for your time, for your attention. Thank you all to all speakers, Andrew, Blair. It was an amazing session today. I hope it was very useful for everyone. Yeah, thank you. And we will be waiting for you on our next upcoming sessions. And you can see the agenda in our LinkedIn. Please join us. We'd love to share all knowledge. And also, we used to invite some really cool speakers from industry leaders, companies, and I hope you will join us also and learn from them. And let's learn together, and let's do this journey of AI development very fun and very productive. From my side, thank you so much again. I hope that we answered all your questions and gave us all the links. I also shared my email, so you are very welcome to contact me, as well as you can contact Blair and Andrew and all our team. Thank you, thank you, thank you everyone, and see you on the next event, on the next session.
See ya.
Thank you, Andrew. See you.
All right, thank you.
Bye-bye. Have a nice weekend.